Good afternoon and welcome to the session Industrial Artificial Intelligence. We have the pleasure to have Mrs. Olympia Brikis live from Germany. Mrs. Brikis is an artificial intelligence research engineer in Siemens based in Munich. She's also a visiting lecturer for AI courses at the University of Bremen and University of Salzburg. Mrs. Bremen, thank you so much for being with us today. The floor is yours.
Thank you very much. Kalisa Zumera. I will start by saying I will have this talk today in English, as the field and my work in general is dominated by the English language, but you're free to also ask questions later in Greek. I'm sure we'll manage. So welcome everybody and thanks for joining. So as I was introduced, my name is Olympia Brikis. I work at Siemens in the research department of Siemens on artificial intelligence research. And I will share today a little bit of my insights on our work, what type of fields we cover, and maybe how you can embark into the field of artificial intelligence yourself. Let me share what I have prepared for you today. So at Siemens, we deal with a lot of applications of research directions. One of these is artificial intelligence research. And as you may know, artificial intelligence is not only common in the industrial research, in the industrial field, but even more in other domains. No, I cannot share. So anyone who has heard about artificial intelligence has probably heard about applications that don't come from industry, but rather from consumer electronics or game development. So some of you may know that the origins of artificial intelligence are already quite early on. So even in the 1946, we had the first personable computer and thus already first breakthroughs in developing programs of artificial intelligence. The first major thing that is known to most is probably when IBM developed Deep Blue, which was a computer program that beat the back then chess champion. And starting from then, we have many more developments, like when IBM's Watson won Jeopardy, the quiz show, or Apple introduced Siri into our mobile phones, up until to when AlphaGo, a program developed by DeepMind, now part of Google, won against the back then champion Lee Sedol in Go. So we have quite a lot of breakthroughs that have been all facilitated by the increased amount of data that we have available, computational power, and also the research into artificial intelligence. In industry now, we started applying artificial intelligence also very early on. But it is maybe less common on what these applications are, or less commonly known. So as a company like Siemens, we deal with industrial systems of all kinds. So we have departments that develop turbines, others deal with mobility and trains. We have factory automation systems, manufacturing systems. So all sorts of quite complex industrial systems that usually just experts of these fields, so engineers that develop them, are familiar with. And nowadays, what starts happening is that a lot of these physical applications, mainly existing in the physical world, start having virtual applications built on top of them. So you have an automated traffic management system, for instance, or automatic scheduling of your production systems. And all of these virtual applications that often are based on data and artificial intelligence are built on top of this physical world. And it is actually not that easy to combine those two, because you need a lot of knowledge about this physical world, these complex industrial systems, in order to build applications on top of them. I brought you some examples of what these applications could look like. So we developed quite a few of these at Siemens. We have over 200 researchers just in our research departments, and many more data scientists and engineers working in the product departments that also try to build now these kinds of solutions. And they range, as I mentioned, through all types of applications. So we have edge devices that allow you to compute artificial intelligence models and make predictions on the edge of your factory. So meaning that you just plug in some little device into your factory and it lets you make predictions about what the demand is or what the production system should produce next. We have artificial intelligence that support autonomous decision-making for planning of different sorts. We have artificial intelligence in product lifecycle management. So all types of software that allows engineers, for instance, to design parts and design the producibility process, and so on. Moreover, many of you probably heard of autonomous driving. This is also a field that is currently very busy in the industry, be it for personal cars or for electrical and autonomous mobility, like in trains. So as you can tell, the applications are very, very broad, and there is many interesting use cases that we tackle here. But all of them have kind of one thing in common. And that is that in order to tackle them and in order to build robust and reliable applications in this field, you need to quite well understand the field that you're looking at. So the industrial system that you want to build something in. So say you want to build a error prediction model for your turbine. So you want to predict when your turbine overheats, and you want to be able to automatically say, oh, this turbine is going to overheat today. Please turn it off before it causes any big damage. So this is a very common application of anomaly detection that is in high demand in industry. When you want to build something like that, you may start by building a model, and you may start by having one turbine in your laboratory where you test your model on. But if you want to actually deploy such a solution into the real world, or maybe sell it even as a company like Siemens, you have quite a lot more challenges along your way. Because imagine you deploy your model and then the turbine of your customer is slightly different than the one that you had in your laboratory. This can cause quite a few problems. For those who know a little bit about data or maybe work in artificial intelligence themselves, surely know that these models are quite susceptible to the environment. So they may work on one turbine, but when you have a customer turbine that maybe has been changed a little bit or is a slightly different type of model, then the model might not succeed anymore. What does this mean? So this means that you need to understand the domain that you are in or that you're trying to build a product in quite well. And this can mean very different things. So we show this picture that we have here on the slide quite often, and it shows how many different types of domain knowledge can play a role when developing such systems. So you might need to know about failure and possible remedies of your products. You might need to have condition thresholds that also are kind of in the expertise of the engineers that build these systems. And all of these things you need to consider when you want to develop an industrial artificial intelligence application. If you do consider them, you are quite powerful because you have something, all of this knowledge allows you to truly build very powerful additions onto your physical systems. And the potential grows with the amount that you can better understand your data. So if you just look at the data in its very raw format, then it is not worth very much because it's messy and it's not contextualized. And the more you go up, the more you clean it up, the more you contextualize your data, the more value it can bring to your application and the better it models the world that you want to build your application. Now, this domain expertise or this amount of domain expertise that connects to industrial applications is very broad, as these industrial applications and products are very broad. So if you want to build something for trains or for mobility applications, you will have to incorporate these people in the process, or these experts of trains, of traffic systems into your design process, into the application development. Whereas if you venture in the world of turbines and anomaly detection on turbines, you will have to incorporate these people there. So this is something that we deal with quite a lot in our daily life. And this can be a challenge, but it can also be an opportunity, in my opinion. Because in order to build these successful industrial applications, you need cross-functional teams. And this is an opportunity for anyone who wants to join in the field, but maybe is not strictly from an engineering background or from an artificial intelligence background. What I'm trying to say is that in order to actually have a fully developed application that you can bring to a customer, that you can bring into real life in industry, you need many players that come together to build this. And for one, this is the mentioned domain experts. So the people that understand your domain very well and can answer you any type of questions you as, or the team as an artificial intelligence engineering team may have. In medical applications, these are doctors. In the case of turbines, these are turbine engineers or mechanical engineers. But the domain experts can be very different. If we go out of industry, they can be teachers, or they can be anyone who simply will use the solution and knows the domain well. Obviously, besides that, we need somebody who deals with the actual algorithms, with the development of the solution. So these are the, what I put here in the middle, the AI researchers. So somebody like me who can then, based on the problem, select the algorithms that are needed to solve it. Oftentimes, AI researchers are also supported by other functions, or not oftentimes, they need to be supported by other functions because they cannot do the rest of the work that is needed always on their own. And some of these roles include, for instance, data scientists, who specifically deal with preparing the data that is used then in these industrial AI applications, or it's used to train the artificial intelligence models. Other supporting functions can include data engineers that build the whole infrastructure for the data to be processed and to be deployed. Similarly, you need software developers. Very much you need them because most of the time, if you are an artificial intelligence researcher, or if you're more of a researcher, then you don't deal with the hardcore productive software development, or you don't want to deal with it. Or you may be even not the best person to deal with it. So in all of these industrial projects, there's software developers involved that support them in developing the necessary solution that stands in the background of these AI systems. Since most of these systems do interact with users, we have another category of people that are needed, and these are the user experience designers or UI engineers, UX researchers that figure out this side. Moreover, if you already have such a complex team, you need people who can structure all of this. And this is also a major need or major career opportunity for people that might not be from a technical field. And that is this product, process, and project management landscape. So here in industrial AI, you need people that have a good understanding of what the technology is like, but can also work with such interdisciplinary and cross-functional teams and make them come together in a successful way. So as you can tell, when developing industrial AI systems, the system is a lot more than just the model or the AI, the core that's in the core. It is a lot of other people and a lot of other functions that need to come together to develop this product. And if you come from university, and if you're maybe studying computer science or are venturing in artificial intelligence, I know from my own experience that the world is always quite focused on just the models, just the AI, and these other fields don't get mentioned so often. Well, as soon as you embark into developing productive applications, you will see that these parts play a very big role. Now, moreover, the fields of application can be very different. So AI can relate to applications of speech and vision or motion, and these are other building blocks that play a role. What I want to sum up with is the thought that, in my opinion, anyone who's interested in the field can kind of find a role in this whole landscape of profiles that are needed to develop these applications. And oftentimes it's about finding this right role for you. So what do you bring to the table? Are you somebody who maybe studied biomedical engineering and has a little bit background there and now wants to go into data science or artificial intelligence research? Then try to find your unique selling point exactly in that combination, because we see more and more that these combinations of qualities and qualifications are needed to develop successful applications that can then really make sense in the real world and be well applicable there. So that's the thought for the end. And if you think maybe what is really the difference between now such a big company as Siemens doing this kind of work versus a small startup doing this kind of work, we like to show this funny picture in the end of our presentations. Basically, as a company that has been in the industrial space for very many years, there's a lot of data and domain know-how embedded within our colleagues and within the company itself. So as an engineer, as a computer scientist coming into the field, there's a lot to find and a lot of applications to discover, which I find quite interesting in our daily work. Thank you. This is what I've prepared for you today. Feel free to ask questions now that you may have. And also, please feel free to reach out if you want in the future. If you still have a question that you don't get to ask now, you're welcome to email me.
Mrs. Brikis, thank you so much for this very, very interesting presentation. A question that we have is, do you normally work on different projects at the same time, or do you normally work on one project and then you move on to the next one after it's finished, after the first one is finished?
Mm-hmm. That is a very interesting question. And I have to say it depends. It depends on the size of the project. So if projects are very large, then we do end up working on just one project. But oftentimes projects are smaller budget-wise, and then that means that you're split up between multiple projects. Yeah, but especially in the research department, there is you have some freedom of saying what you would like to do, and if that's possible, usually people try to accommodate that.
Great. Now, if someone wants to become an AI researcher like yourself, what tips do you have for this person, especially if this person is studying in a Greek university?
Mm-hmm. So the tips I have, first of all, learn as much as you can. Because as soon as you get into applying your knowledge, there's not so much time to venture into new methods and technologies. Obviously, you have time to study and train on the job, but usually the setup is in this way. Somebody comes to you and says, well, you're an AI engineer, and I have here this and this problem. Can you solve this for me? And then you need to be quick on your feet and go through all the methods that you learned in school or at university and figure out which one probably suits the problem best. And so the more knowledge you bring into your job, the better you can make the selection, in my opinion. So for what? This is the first point. Study, study, study when you're at university. Second of all, gain practical experience. So for any employer or for anything you want to do, it always is good if you know the academic side, but if you have also seen kind of what application is like. And this does not necessarily mean that you have to do an internship in an AI research lab. It can be a software development internship, for instance, where you gain experience on how to develop productive software. It's very helpful for later on. So a combination of doing the theoretical work at university and gaining experience in industry or in more applied fields, I think is a very good starting point.
Thank you so much. Now, in order to come up with an algorithm, what do you do exactly?
Mm-hmm. That's a very good question. So I think everyone has a slightly different way of going about it. But what is quite essential is understanding the problem. So what I like to do is I like to truly understand what the people that came with this to me, so usually we call them the domain experts that came from the domain, what their problem is. I try to really deeply understand that. So usually this involves quite a bit of talking to them. So here you have to develop some skills on what the right questions to ask these people. And then as soon as you understand the problem, their problem, we also like to call it the business problem, then you need to go into the second step and try to find the matching AI problem. So not always do these two things match. So somebody might come to you and say, well, you know what, I have to analyze these log files every day, and this is this takes me so much time. I'm a service engineer, and please help me with this. So you can understand his problem, but this does not translate to any predictive problem or any model that you can build right away. So you need to do this step. And this is probably the most difficult, and what you are also hired for, in a sense, as an AI research engineer in industry, is to make that jump. And to do that, you need to, as I mentioned, have a good understanding of what AI can do for you in terms of solutions and models that you can build, and then try to match them. And this is a combination. This is done by looking at multiple factors. So you have to look at the data that is available to you in this use case or in this problem that was described. You have to look at your computational resources that you have. And then obviously also on the potential success of a model. And then maybe you have a selection of 2 or 3 methods or problems, AI problems that you could solve, and you go back and iterate with your customer or with the person that needs this problem solved.
Brilliant. A question that has just come through, it says, is a PhD a necessary requirement for an AI researcher, or an MSc suffices?
Mm-hmm. So in my opinion, there has been a little shift lately in the answer to this question, or in whether this is needed. So I would say like 10 years ago, you probably did need a PhD in order to go into AI research, simply because AI research was also not taught that broadly at university. Whereas nowadays, a lot of people with a master's degree come out of university with broad knowledge of AI. So similarly to me, I graduated at the University of Munich in computer science, and I focused a lot of my master's program on computer science and data analytics. And combined then with some experience that I had in our research unit already, this was a good starting point for me. So I don't think it is needed, but you also need to ask yourself, what do you really want to do? If you truly want to do research, write papers, be very deep in that academic world, then it kind of still does remain a requirement. But if you want to go into the application of AI in industry or in any other field pretty much, then I would say if you brought extensive knowledge from your master's program with you, and you have some experience, maybe you already saw the field once or twice through an internship, then go ahead and try and apply. I think it should work out.
Fantastic. Now we've got just 1 minute left. A very quick answer to this question. Everybody says that Greek engineers are really good. And the question is, do you think that Siemens one day will set up a research center on AI in Greece? Do you think that would be possible?
I mean, I sure hope so. There's always talk about opening up new things, and stuff develops, especially now after the coronavirus crisis. We see that agile methods and AI is even more in demand in Europe and everywhere. So I think there's hope that something could happen, but we'll just have to see and wait. There's other people making these decisions, but I don't think it's out of sight totally.
Fantastic. Mrs. Brikis, thank you so much. It was really, really interesting. And thank you everybody for watching.
Thank you to everyone.